Good morning everyone and welcome back to section 2.5 solving compound inequalities part B. So last class we were solving the and graphs, right? Two graphs that come together, using a compound, just like something, right? Two inequalities that we put together, right? Well, we're also putting two inequalities together today, but instead of and, we're going to be using or. So last class we had 2 points and we shaded everything in between. Well, we're going to have the same 2 points, but instead of shading in between, we're going to be shading the opposite, right? So we're going to be shading this way. These ones are easier to spot because it's separated by or. All right, so example 1, we have to, just like yesterday, we have to translate these words into a compound inequality. So, exactly the same as yesterday, we're going to split this into 2 parts. All right, so a number x is at most 0 or at least 2, right? So, a number x is at most 0 or at least 2. So, we need x, we need 0, right, for the first one. At most, right? Could it be less than 0? Sure. Could it be 0? Sure. So x could be less than or equal at most, right? At most it could be 0, but it could be -1. It could be -100. It could be negative infinity, right? It doesn't matter. It could be at most 0 though, right? Or at least 2, right? So x is at least, right? It could also be 2. It could be 2, but it needs to be at least 2. So it could be 2, 3, 4, 5, 6, right? And when we go and we graph this, just like yesterday, we will have our graph. We'll only put 2 points. So we'll have 0 and 2, right? 0 is going to have a closed dot and is going to be shaded to the left, right? The arrow points to the left. So we're going to shade to the left. What 2, the graph is going to be shaded to the right, right? And it's going to be a closed dot, shaded to the right. And when we put that on the graph, we'll have a closed dot at 0, shaded to the right, and a closed dot at 2, shaded to the left, right? So this is how an OR graph looks, right? It's a little different, but when we go and we write the inequality, we just say this: x is less than or equal to 0, or x is greater than or equal to 2. And this is our answer. So we actually put the word or in there. So when we go and we want to go from this to graph, well, if we see or, we know it's going to have to be this type of graph, right? If it's the small number x, we know this is and, right? So this is going to be and. Or graphs have the word or. So let's see, just like we did yesterday, in all or graphs, we'll have 2 points, right? They could be open dot, they could be closed dot, they could both be open, they could both be closed, it doesn't matter, right? It depends on the sign that we're using. And they will always point in opposite directions. So this is always what an OR graph looks like. When we go and write the inequality, it will always have the word or in 2 separate inequalities, right? It'll always have 2 separate inequalities, and it will always look something like this. All right? So let's go with example number 2. Example number 2. A number x is fewer than 6 negative 6, I'm sorry, or or no less than negative 3. Okay, so we have this. We need to write our two expressions. So we'll put expression 1, expression 2. So we have a number x is fewer than negative 6, or no less than 3. So we have x, we have negative 6. What does is fewer than mean? Is fewer than, right? So x is fewer than negative 6. It can't be negative 6, right? But it could be fewer than. So x is less than negative 6. Well, our next one, we have x and negative 3. And what sign does is no less than? Is no less than. Could it be 3? Sure. It can't be less than it though. So x could be greater than or equal to 3. Right? So a number x is fewer than negative 6, or x is no less than negative 3. So when we go and we graph it, we want to put the larger number on the right, which is negative 3 in this situation. And we want to put our lesser number on the left. Negative 3 is going to have a closed dot, and it's going to be shaded to the right. Negative 6 is going to have an open dot, and is going to be shaded to the left. So when we put this on the graph, we have an open dot at 6, a closed dot at 3, shaded in opposite directions. Finally, to wrap this up, if we were to write this in one inequality, we're going to have x is less than negative 6, or x is greater than or equal to negative 3. And that is our answer. Is our answer. Hopefully it's starting to click for you guys, right? The difference between an and graph and the difference between an or graph, right? It's nice that the or graphs have the word or, so you're like, well, it has or, it must be an or graph, right? So hopefully we could start making those connections. It'll make it super, super easy in the future as we continue going towards this. All right, plus we have to really start coming down on these. The test here is just in a few days. Our exam is scheduled for the 27th. The 27th. All right, so next. We have solving compound inequalities with or, right? So what we're getting at, solving compound inequalities, what we just did was translating. So we have 3x minus 5 is less than negative 8. Or 2x minus 1 is greater than 5. Well, just like we did yesterday, we split it into 2, right? Well, the nice thing about the or, it's already split in 2. So we could almost just, build a wall right here. We're not going to pass the wall. We're going to do whatever over here, graph it, and write our final inequality. Okay, so first we want to add 5 to each side. Right? So, -8 plus 5 gives us a -3. Bring our sign down, 3x. When we divide by 3, we're going to have x is greater than -1. This is going to be the first one. Over here, we're going to add 1 to each side. 5 plus 1 gives us 6. Bring our sign down and bring the 2x down. Divide by the 2, we have x is greater than 3. When we go and graph it, our large number is going to be on the right. Let's kind of bring it in. Our large number is going to be on the right. Our small number is going to be on the left. We have an open dot. We have an open dot at -1, and we're going to shade to the left. We have an open dot at -3, and we're going to shade to the right. All right, now, writing our final equation, we will have x is greater than -1, or x is less than -1, or x is greater than -3. All right, so not too tough, not too tough. Hopefully you guys are starting to really pick up on it and really master it. This one's nice because you can just put a wall straight down, and this is that side, this is this side, and at the end we're going to combine it all together. All right, in the graphing, you guys are probably professionals now at graphing. We've been doing this every single day. So, the next one is going to be a U-try. It's going to be a U-try. So, U-try. We're going to have 4x plus 3 is greater than, or I'm sorry, is less than or equal to -5, or x minus 8 is greater than -1. So, try that one on your own, and in a couple minutes we can go through and see if we got the same answer. So remember, the first thing I would do is build that wall. Build the wall between or. And then solve the left side, solve the right side, graph it, and put it all together. All right, so let's begin. So first, we build that wall. We're gonna add 3 to each side to give us, we're gonna subtract 3 from both sides to give us a -8. Bring our sign down, 4x. When we divide by 4 from each side, we're dividing by a positive, so we don't need to change the sign. We'll have x is greater than or equal to -2. We're going to add 8 to each side here, right? When we add 8, we'll have x is greater than, what is that, 7? Perfect. X is greater than 7. Both of them are in graphing form, so when we go to graph this, put the small number on the left, which is -2. Put the large number on the right, which is 7. We have a closed dot at -2, and we're going to be shading to the left. We have an open dot at 7, and we're going to be shading to the right. And when we put this all together, we will have x is less than or equal to -2, or x is greater than 7. And this is our final answer. Thumbs up. Hopefully you got it. Thumbs up. Perfecto. All right, so you can check your work here for a second. All right, hopefully we all matched up. So, the homework for today is also going to be kind of all over the place because we are sharing the pages with the and category. So it's going to be the same as last night, page 85 to 86. Numbers 5, 6, 8, 9, 15, 16, 17, 20, 22, 26, and 28. That should only be 11 problems. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, there's only 11 problems, so it's not that bad. It just kind of skips all around the page, right? And it will only be OR graphs, so it's not that bad. Please show all of your work, and I will see you back here next time where we will be doing section 2.6, which is absolute value, which is awesome. All right, so good luck. Make sure you email me, or if you need to have one-on-one time, come to my office hours from 2 to 3. Have a good day.